Great. Thank you very much, Lori, for that kind of introduction. Hopefully, that doesn't mean my ideas are too crazy, that they're invalid. In fact, what I'm going to suggest to you today is maybe you don't want to go too far from your domain expertise. So you'll see if I've strayed too far. But anyways, it's great to be with you all. Thanks for coming. Let me just tell you a bit about my co-authors. So Ryan Hill was a MIT econ PhD who worked as a postdoc with me this past year and is now starting a tenure track job at BYU. Jan Yin is a PhD student in McCormick here. Carolyn Stein just completed her PhD in economics at MIT and is taking a job at Berkeley in the economics department and in the business school. Darshunan is a colleague here at Kellogg. He's actually a physicist going to interdisciplinarity and is in the Moores department at Kellogg as well. Okay, so this is a bit interdisciplinary in some sense. And reflects kind of a big data approach, a descriptive approach to thinking about what's going on in science and in creativity and innovation. So just to motivate this, I know we only have an hour, so I'll try to be precise and to the point. So, science and innovation, we're always, as you can reflect, we're always facing evolving questions, new things come up, new challenges in our discipline and in the world that we see. So we want to think about how we can adapt as individual researchers, to new opportunities, new demands. Of course, society as a whole and science as a whole is trying to adapt to evolving circumstances, whether it's climate change, and that's very much in the minds this week with Glasgow, or COVID pandemic, for example. And there's an idea certainly in business, very strong idea, that sort of organizations fail because they failed to adapt to new technological opportunities. And so, the paper's really trying to get at, what do we know about this? How do you adapt personnel, researchers, R&D workers, including ourselves, to new opportunities and challenges? So we're going to sort of study that in science as a whole. We're using a lot of data, but we're also going to have a key application to what's going on with the COVID-19 pandemic from the research side. Who has jumped in to do COVID-19 research, and how has it gone, depending on how far away it was from what you were already doing. So I want to think about it that way. And just to put another layer of sort of motivation here, so, a language you see a lot is, for certainly the organizations literature, is about, exploit versus explore. Should I, as a researcher or organization, continue to exploit, meaning do what we kind of know how to do, right? Or should we explore more widely, go reach further from what we already do? And there's a sense that organizations often fail because they find it difficult to explore successfully, and get sort of overtaken by new entrants. And one reason is maybe it's just hard to explore, right? Because you're trying to reach into areas where you may not be as steeped or as expert. I have a lot of work that kind of builds on this idea that we become more narrow as science and technology progress. We become more sort of narrowly specialized, which I'll come back to. On the other hand, exploration might be really productive, partly because whatever you keep exploiting the thing you're doing, maybe you've plucked the low-hanging fruit, you're running out of good new big ideas, and so you kind of need to refresh. So you're kind of running away from maybe diminishing returns in your area. And then there's, in creativity, there's this idea that sort of novel combinations, people kind of come at it from a new angle, that might be especially high impact. Maybe it's risky, maybe you're likely to fail, but also maybe that sort of really unleashes new possibilities and kind of has an upper chance of, really home run work. And that sort of reflects in a different idea, a related idea, that we might think that outsiders have some kind of creative advantage. Like you see that in entrepreneurship, and sort of the media attention to sort of divergent thinkers entering from outside of an area and maybe having big ideas. And then, of course, we talk about it may be hard to reach beyond your knowledge boundaries yourself, but of course you can always collaborate with others. So maybe a collaborative format allows you to kind of extend your reach in a meaningful way and get to high impact. Yeah.
Sorry,
Right.
it's whether the insiders agree on whether something is good or not, right? And that is kind of like, I think that's the most important part why exploration is hard, because the referees in another field will not give you the benefit of the doubt.
Or maybe understand what you're saying.
Or even that.
In a new way. So yeah, it could be. So there's sort of both a sort of supply side and a demand side, or sort of a producer side and then a audience side aspect, which might make exploration hard. You could be ahead of your time, these kind of ideas. So, what are we going to do operationally? I'll show you in a minute. We're just going to look at whether a paper is high impact, meaning whether it's heavily cited. You can also do this for patents. Now that, of course, just mixes these things. It doesn't distinguish them. It may be that, you're not heavily, you may have a brilliant idea. It's the best idea in the field, but no one cites it because they don't quite get it or they're not really aware of it. So I'm not going to be able to separate those. But on the other hand, when you think about sort of having an influence, if no one appreciates what you're doing, it's not having a huge impact, at least initially, right? So I think it's still, without pulling apart those mechanisms, we do care about impact, I think. Lori. Well, if why don't I take questions as we go, and then I might shift the rules if we run out of time. Diane. No. It was a good question. It was an important question. All right. And then have some Q&A at the end. Is that what you prefer? Okay, let's do that. All right, so please hold your questions. All right, so what are we going to do in this paper? Actually, we're going to kind of take a big data approach to kind of do a high scale measurement framework for thinking about how far you are when you move in, when you write a new paper, how far is it from what you already wrote, basically. And we're going to apply that to scientific and social scientific papers kind of since 1970 using a more or less all science literature. And then we're going to also directly apply it to COVID-19 research in 2020 and kind of compare it against other 2020 research that everyone has been doing. And we're going to say, do we see an outsider advantage? What is the outcome when scientists reach further from their normal work? Who produced related to high impact COVID work? Was it the insiders? Was it outsiders? Maybe you've written COVID papers. I know, like, this is a COVID paper in a sense. So now I've written a COVID paper. Actually, it was my second COVID paper, which maybe I shouldn't have done, will be the lesson from this paper. But anyway, okay. So you have novel measurement, high scale, new empirical regularities, not a causative analysis, just to be clear. So we can think about a variety of interpretations of what's going on. Although we'll also look kind of within your own choices. So we'll see what happens when a person is moving further or nearer to their own work. So we get kind of an individual fixed effect as well. All right, so the data, we're using a data set called Dimensions, which comes from a company called Digital Science, who produce like Overleaf and a variety of other things you may know. They are kind of equivalent to Google Scholar. Google Scholar won't share its data. So there's Microsoft Academic Graph, which has been freely available, but they've now shut their team. So Dimensions is not freely available, but we have a relationship with them. So this is basically, these are also guys who produce altmetrics, and they track science uses in media or Facebook or Twitter, because they have very large data sets. We're looking at 45 million scientific articles since 1970 through the end of this past calendar year. It includes publications and preprint servers. So obviously for like COVID, we want to look at the working papers too, and it has like SSRN and all the archive databases, includes NBER, by the way. And then they have citation links between all the papers, and they have name disambiguation, which is imperfect, but we could talk about. And they're going to classify all these papers into fields. There's kind of a high level, level 0 field. There's 22 different level 0 fields for all of science and social science. Then there's 154 level 1 fields, and then there's sort of level 2 fields. It goes on and on. All right, and then we're going to restrict, to get to the 45 million, we're restricting to papers that make at least 5 references, because here's Jan, who's one of the co-authors on the paper, by the way. Restricting to papers that make at least 5 references, that makes you more confident that it's a scientific research article as opposed to like a short comment. That's just one way to kind of further restrict within the data set. Okay, we also need references to do our method, so that's also relevant to our framework. Oh, I'm not allowed to take questions. I am allowed to take questions. Okay, it has to be clarifying. Well, I can take off my mask. I'll just take off my mask.
Just a quick clarification. When you refer to scientific articles and scientific papers in the fields, could you just tell us a little bit more about what fields or domains are included within that versus not included?
So it's basically all fields of research. So think it's like what's on
humanities and social sciences and
yeah, every field of science and social science. Think about it. These are like web, like Google Scholar or Microsoft Academic. They're crawling the web and pulling all documents that are PDFs that look like a paper. And basically, is what they're doing. Okay, the original version of this was Thomson Reuters Web of Science or Web of Knowledge. These are kind of the bigger and updated versions of what they were doing. That's also a proprietary data set, so it can be kind of hard to access and use. Okay. All right, so just to start with some facts, I'm going to just look at COVID for a second, because I think it's interesting, and then we're going to kind of get into our measurement framework and the substance of the results. But just to show you, so here's green is the fraction of all papers by month that are coming out that are about COVID. In in 2020. So in January 2020, there's really no papers. And already by, April, a little bit over 4% of all papers coming out have kind of COVID in the abstract or title. And then that kind of plateaus to a similar level throughout the year. So you end up with about almost 100,000 papers in 2020 that seem to be about COVID, okay, from all sorts of different fields. Okay, so people kind of really got into COVID, and not surprisingly, we saw a lot of that. That probably echoes your own sense of what's going on. And then you can look at it by field. So here we're taking the 22 high-level fields. And so you can see the number one field for COVID in terms of the fraction of papers, and not surprisingly, is medicine and health, where you're getting close to 7.5% of papers. And if you look down a level, like into like immunology, it's going to be like 15% of papers. Okay, so that's, but you also see like a lot of social sciences, right? Economics, education, law are there in the top 5 or 6. And again, suggesting just the broad effects of COVID is sort of affecting everything in society. So people in education are like, how do we deal with this? And law, what can the law help us do with this? Economics, what does it mean for the macroeconomy and unemployment, and et cetera, et cetera, et cetera. So you're seeing a whole wide range of research across the waterfront, really, of fields. Now, there are some fields that see much less, but even in the earth sciences, they're still writing about COVID to some extent. Okay. Just a brief taste of that data. All right, so now the measurement framework we're going to use, which you can maybe come up with other measurement frameworks, but here's the kind of the one we developed and applied, and we're in the process. Actually, Jan is applying it right now to patents, and we can tell you about those preliminary results too, if you're interested. Okay, so we're trying to say, how far did a researcher move from their prior work? We want to get some kind of index of that. And so what we're going to do is take an author, a person I, and take a particular paper, say written in 2020, call that paper J. And then we're going to define 2 vectors. Look at Rij, which is the reference vector, the list of references in the focal paper. Okay, so take all the references, all right? And what we're going to do to kind of get some kind of coding of knowledge, and whether you're sort of sticking to what you normally do, we're going to look at the journals that you're citing. All right, so if you wrote a paper in economics and it was like, QJE, Restat, AJ, Micro, those would be the journals. And we'd get a frequency count of all the journals that you're citing. And it's a very long vector because it's all the journals in the world, but you're going to cite a very particular set of them. All right. And then we're going to take for you across the union of your work up to the prior year. So like 2019 before, we're going to take the union of references across all of your prior papers. Okay. And then we're just going to look at the cosine similarity between the vector for this particular paper in 2020 and the pool of all your prior work. Okay. And you can do this for like all your prior work, or you can do it for say the last 3 years of work that you've done. I'm going to show you data for the last 3. So it's your current paper versus the last 3 years. Maybe there's some drift in your agenda, but actually the results look very similar when we do it for the whole body of prior work. Okay. So that's the measure, pretty straightforward, standard thing. So cosine similarity. So a 1 means this is just like your usual distribution of journals that you cite, and a 0 means it's completely orthogonal. These are citing completely different journals. Sorry, I had that backwards, doing 1 minus. Okay, so I now confused you. So a 1 will be a big pivot, will be like, this is an orthogonal set of journals to what you normally do, and a 0 means it's exactly the same as your normal journals. And just a picture of this. So imagine this is your prior work, right? You have a bunch of articles that you're an author on, okay? And these are the references, coded kind of color means different journals, right? So you might have cited, QJE twice in this paper, right, et cetera. And so each one, and then you union all of those to get your background vector, okay? And then let's take a paper in this year, 2020. Here's one paper you wrote. Here's another paper you wrote in 2020. And those are the journals in those papers that are cited. And we're just going to look at the cosine between these journals and that. These look very similar visually. That's going to be low pivot. You didn't change much from normal. And here we're looking at a very different set of journals than you normally do. So it'll be a high pivot. Okay, so that's the measure. And the value of that, of course, is you can just do it across the entire corpus of work. All right, so what does it look like when you do that? So here are the blue. These are all the papers in Science in 2020. And the red are all the papers in 2020 that are about COVID-19. Okay, so the first thing is look at the blue, and you see that there's quite a wide dispersion of pivot sizes. So sometimes people, maybe central tendency around 0.6 in this measure, people are moving different amounts from when they write a new paper. And then COVID is clearly a huge right shift, where people are pivoting far more than they normally do, according to this measure. Okay. So it's kind of taking you up for a spin, if you will, this measure. And then you can look at it in a couple of different ways. So on the left, we're going to now track a cohort of researchers who started in 2005, meaning their first publication appears in 2005. And we're going to look at people who wrote a COVID, who started in 2005, whatever field you're in, and you wrote a COVID paper in 2020. Okay. And then we're going to match you to other people in your field and year who started in the same time and have the similar number of publications and sort of citations as you do in your field to kind of match cohort. And we're going to look at their pivot behavior. So these controls don't write a COVID paper, but otherwise they started in the same year with the same productivity. And so you can see how much people are pivoting on average. It's sort of pretty stable over their careers. And then the COVID authors have a huge pivot, unusual for them. It's unusual for them compared to what they did before. It's unusual for them compared to what they wrote, other papers they wrote in 2020, and it's unusual compared to their control group. So, you see at the individual level, people are really kind of pivoting quite far compared to normal when writing a COVID paper. And on the right, these are the 150 or some fields, level 1 fields, okay? And here's the average pivot size across all the papers in 2020 from that field that are not COVID. And here are the COVID papers. And you can see that basically systematically in every single field, when the COVID papers show bigger pivots. So people in all, whether it's economics or immunology, people are moving further than normal to write COVID papers. Okay, all right. Now, the pivot penalty. And this is really the finding of the paper. So what we're going to do here is we're just going to look at, this is now all of science, sort of since 1970. Let me tell you about the vertical measure for a second here. So we're going to take a measure for citation impact, as I referred to earlier. We're going to measure kind of a high impact paper as one that is in the upper 5th percentile of citations received among all papers published in that field and year. So we're going to sort of normalize, some fields have more citations than others, but we're going to normalize this because we're only looking within your field. And here we're using the 154 different fields, okay? And so we're asking, among all the papers published in 1986 in immunology, was your paper in the upper 5th percentile in terms of citation impact? And that'd be it, right? Okay, that creates a normalization that this is fairly typical in this kind of work, try to even out citation differences, and then to focus on very high impact papers as an outcome measure, so kind of a home run, okay? And so by construction, your baseline probability of a home run is 5%, okay? And then what you see is that as you move from low to higher pivots, you see basically a systematic, nearly monotonic decrease in the probability of a home run. So the further people are moving from their prior work, the less likely you're getting a home run. So that over here, you're at 2% percentage point probability as opposed to a baseline of 5%. So you're much less likely. And up here, if you sort of stick to what you're doing, like this is what I always do, your chances are like 60% higher than the baseline rate. Okay, so that's sort of the core finding. We didn't know what we were going to find. Okay, now I'm going to try to push this a bunch of different ways, but I might have thought, like, yeah, maybe it's like a U shape, or it's like you kind of like you take the big risk, and maybe it goes badly, but maybe you get more home runs, kind of way out there. But what we're seeing, at least at this measurement framework, with this 4 to 5% home run rate, you just see kind of it just gets worse as you go to the right, right? And we'll dig into that further. But first of all, here's another fact. So if you do it by sort of the decade, 70s, 90s, and 2010, so this is when the paper was published, you're seeing that this pivot penalty, so here's like here's the 2010s is the red, and the blue is the 1970s. You see a worsening pivot penalty with time. So like the penalty for pivoting now is higher than it used to be in terms of impact of work. Okay, so these are descriptive. We're comparing within individual in the sense your measure of your pivot size is always within you, but also we're comparing across individuals with different impacts. So there may be some unobserved heterogeneity going on here, but there's sort of a striking fact when you look at everybody together, at least at this level. Okay, so but maybe the 5th percentile is not where the action is. Maybe that's not good enough, right? So maybe there is a U shape, but it's like at an even higher threshold of like the incredible, rare, novel idea. So here what we're doing is we're looking in the upper tail of citation, like your probability of getting to a 90th percentile paper, 95, 99, 99.5, 99.9, it's like the upper 1 in 1,000 paper in that field and year in terms of its impact, okay? And then we're looking at, that's got a baseline rate, this would be 0.1, it would be 0.1%, right? And then we're looking at an odds ratio. So if you are at 1, you kind of have this random baseline rate of getting a high impact paper. And then the red dots are low pivot papers, kind of the lowest, say 10 or 25% of papers. I think this is 10%. And then the blue is the upper 10th percentile, the high pivot stuff, Okay. And so you see basically that you're continuing to do even better in the very, very uphill tail by staying where you are. And that is, and then you kind of get down to maybe a half or less 40% chance of compared to the baseline rate of 1 when you're in a high pivot state. So we really don't see, even as you go super into the upper tail, we're just never seeing this evidence that suddenly high pivot is winning, right? Or that sort of sticking to what you do is kind of now a penalty. You can't do something really, really high impact. So the very, very highest impact work is like privileged by being low pivot. Of course, there is some high impact work here. So it's not like there's just that you're much less likely to do it. Okay, yeah. So are you worried that this is review articles that are, yeah. So we have not in this tried to eliminate review articles, have we? No, so it would still include review articles. Yeah. So there are ways to do that. I'm going to do this with an individual fixed effect in a minute. So in a few minutes, so if you think it's about some individual who's just really highly cited or not, and their tendency to pivot, I'll deal with that in eminence. But another thing we could do, which we haven't done, is you can get rid of, you can either try to look for a coding for review, but that's not so great usually, but you can cut papers with large numbers of references, which can often signal that they're review papers. Or you could look within bands of references, which I don't think we've done either, but we could. I will say though, however, yeah, these facts are also going to, I'm not going to show you them, but I know, but they also appear in patenting. So that there's a pivot penalty that's steep and it's rotating down with time. So it's getting steeper. And that's the context where we don't have review patents. So, and it's a completely different set of institutions, and yet we still see them. So that, I think that can be useful only in, if you're looking for Occam's ratio, which maybe we're not. But it's just something that's going on that's very general and crosses a whole bunch of different institutions. Okay. All right. So, okay. So now we're going to come to COVID-19, right? And so what's going, is it different for COVID-19 or not? And so now you're going to see something it is different in a way, but not in another way. And so here's what you see. So now blue papers are papers in 2020 that are not about COVID-19, and red papers are papers in 2020 that are about COVID-19. Okay. Now it's 2020, so we don't know how heavily cited these papers are going to be yet. It's too soon to tell. So we have to come up with something else. So what we're looking at here is journal placement. Okay. And our journal placement measure to create evenness, again, we take any journal and we look at the proportion of papers in that journal that are home runs, like in years before. Okay. So like in Nature, it's like almost all papers are in the upper 5th percentile, and in a lot of journals, it's like very rare. And then we're basically assigning you, rather than the hit rate to your paper, we're assigning you the hit rate of the journal you appear in. Okay. So that's what we're doing. And so that has some weaknesses, but also, you know, gives you one way to proceed. Yeah. Well, I think we did since 2005. Yeah, do you remember how far we went back for? Yeah, to do the journal hit rate, 2000. Yeah, and they're shifting. Yeah. Right. So we'd have those journals, but we would dump how you did before the year 2000 if you've been around for a very long time. You would still be in the data. We just go back as far as you are, because your journal would be within a field, like a level 1 field, and so we would just pull you with everyone else in the level 1 field and ask what share of papers in your field, in your journal, are in the upper impact within your field. Does that make sense? Yeah. Okay. Okay. So that's the data there. Okay. So again, so the blue, you still see the same thing for 2020 papers. That's the pivot penalty. But with COVID, well, you see two things, right? You see that at any pivot size, you get a premium of impact. You get into a better journal, right? But within them, there's still a very steep pivot penalty. Okay. And you also see, look, these are bin scatter plots. So, you know, the median, as we saw before, right, the COVID papers are shifted towards much higher pivoting. So this whole red thing is shifted over. So the median pivot size is there for COVID and there for ordinary work, and they're actually not too different in a sense what the impact rate is. Okay, so people who wrote COVID papers, they were moving towards a very high demand area, right? And that was a premium in terms of journal placement this past year. On the other hand, those who were kind of able to do that and stay close to what they were doing had a really huge impact. And those who had to pivot very far to engage COVID weren't doing so well. In fact, were doing worse than people who tended to stick to what they were doing. Does that make sense? So you can see the trade-off. Okay, so maybe it's not risk versus reward, at least in this data. It looks like there is reward, but maybe you're moving to a new area that has a lot of opportunity. So it could be AI as a tool, or it could be COVID, or it could be climate change or something. And that could have some kind of impact premium. But for you, the further you had to move to get there, at least in the beginning, the worse it's going to go. This is kind of offsetting optimization. Okay, now what if you do that within an individual in 2020? Things kind of linearize a little bit, but you get sort of a similar story again, right? Where the blue is the non-COVID papers, and we're looking within a person. So this is going to deal with people who have higher or lower impact on average. And you're saying, given a person's sort of average impact, they are doing worse when they pivot more. That's the blue line. And for COVID, they did better than they normally do, but they also did worse the more they had to pivot. Okay, so you can think of that as a dealing with some unobserved heterogeneity at the individual level. Okay, all right. So so that's the kind of central findings of the paper. And so then we wanted to ask, well, can you see some kind of way around this, right? Like, is there some way to, that's on average what happens when people pivot, but maybe there's ways to pivot that are better than others, right? And looked at 3 different parts of this in the paper with some depth. I'm only talking about 2 of them here, but maybe I'll throw the third in depending on our timing. How much time do you want for Q&A at the end typically? Okay, so I'll see where I am. But so one is just teamwork, right? Very naturally, if I don't know a lot about immunology, but maybe I can work with the immunologist, and together we can sort of fill in each other's gaps and do something useful. And we know generally that teamwork seems to be becoming the locus of higher probability, high impact work with time. I'll look at that in a second. So that will kind of go in the same direction. It may be about funding. Perhaps high pivot work, COVID included, just tends not to get funding. You're kind of outside your grant stream. And since you have fewer resources, it just doesn't go as well. So maybe that's what we're seeing. So the pivot penalty is really due to a kind of a funding issue, possibly. But we can look at funding too. The one cool thing about the dimensions data is they've actually integrated, it's a very ambitious data set. They've integrated 600 different funders around the world at the paper level. So if a paper is funded by the NSF or the NIH or the Wellcome Trust or various philanthropies and other sources. Maybe not perfect cleanliness data, but they're trying to do that. So we can look at that too. Okay, so on the teamwork aspect, so this is something that motivates a lot of my work, this kind of issue, and I only in the last couple of years found this quote from Einstein, which sort of said what I was trying to say better. So here he said in 1949, reflecting, he said, knowledge has become vastly more profound in every department of science, but the assimilative power of the human intellect is and remains strictly limited. Hence, it was inevitable that the activity of the individual investigator should be confined to a smaller and smaller section. Right? So in that story, which I've called the burden of knowledge, you just there's more and more to know because of normal science, we accumulate lots of insight, facts, theories, frameworks, tool sets to do research and take the next step. But you can only know so much, you can only be trained in so much. And so you end up with kind of a narrower set of skills at the frontier. And of course, that could increase the value of collaboration because you can then augment your own expertise with complementary forms of expertise. And kind of in line with that, though, you can have other stories. We do see that not only has research shifted more towards teamwork, but that teams seem to be the source of higher and higher impact work. And that's really a reversal. So here's an old paper of mine with Brian Utsi, who's a sociologist at Kellogg, as well as Stefan Vukti, who's a computer scientist. What we're showing here, so it's not very labeled. This is science and engineering. This is social science. That's arts and humanities, and that's patenting. And this is a measure called relative team impact, which basically says, imagine you, to use a baseball metaphor, imagine you came to the plate and you swung at the ball as a solo author. What's your chance of hitting a home run? So an upper 5% paper, upper 1% paper by citation impact. So what's your sort of home run rate as a solo batter? And then to sort of stretch the metaphor a bit, imagine you came to the plate in a team. I'm not sure how that works, but you're collectively swinging the bat. What's your chance of a home run? Okay. And so if it's 1, it means your chances of a home run are the same, however you organizationally come to the swing the bat. Okay. And what you see in the dot here, so this is basically every year we're asking what's the ratio between the home run rate for the solo authors in a field and the team authors in a field. Okay. And you can see that back in like the 60s and the 70s, you see this is a dot cloud. So every field appears every year separately. You can see there were a lot of fields actually where you'd rather be a solo author than a team, in the sense that you had a higher hit rate as a solo author than a team. But once you get to kind of the end of the 20th century, there's almost no fields like that left. And kind of all the fields are kind of above 1. And the black line is the average across, a weighted average across all fields. So you can see, and it's getting very far above 1. So, typically now, like your chances of a home run in most sciences or social sciences is like 4x if you're in a team than if you're doing it alone. So there has been this shift to higher impact. And again, you can think of that for a variety of reasons, but I'm linking it here to the idea that maybe that's because you can aggregate more human capital. And of course, that's sort of in the lens of the fact today is one possible mechanism, which is just it's sort of hard to move outside your own expertise, hard to explore, and it's getting steeper with time, and the pivot penalty sort of consistent with sort of Einstein's idea. Okay. All right. But okay, so then will collaboration sort of solve the problem, right? So, okay, so first of all, here's some data about collaboration in research with regard to the pandemic and in 2020. And so here we have, again, every field, and we're asking what was the number of authors on the non-COVID papers in 2020, and what was the average number of authors on the COVID papers. And actually, in the large majority of fields, these are smaller fields, in the large majority of fields, especially where there's a lot of data, you're seeing, so I guess 77% of fields, you're seeing larger team sizes for COVID than non-COVID work. So people did seem to be typically doing it in larger teams. And then on the right, we actually can look at whether when you have a team member, is it someone you've worked with before in a prior work, or is it new to you team member? And here we're not looking at postdocs who might be new in a lab. We're looking at co-authorships among people who have at least 5 papers already. So are you kind of working with someone new who has an established research record? And you can see that, again, this is sort of the 2005 cohort. And we're going to see how the fraction of papers they write that bring in a new established author over their career. And then with the COVID authors, they kind of are more likely to engage someone by far than they normally do, or the matched set seems to. Okay, so there does seem to be kind of associated with pivoting into COVID, an explicit use of larger teams, and particularly of reaching into new co-authorships. Okay, all right, so but then does the pivot penalty say disappear if you have the new co-author? Well, when you look at it in terms of, so the simple way to look at it, at least visually, is we're now going to divide sort of by big and small teams over here. So we have COVID papers that have big and small teams, and then or other papers with small teams or big teams. And then over here, we're going to say, is that your usual team, the team you've worked with before, or do you have a new established author on your team? Okay. And so, yes, a new established author, no, COVID, non-COVID. And so you can see that when you work with teams or you work with new co-authors, actually there does seem to be an impact advantage. And there's still an impact advantage to COVID in general compared to ordinary science. But at the same time, you still sort of within any one of these organizational formats, there's still a pivot penalty, meaning the further you move, then the worse it goes. Okay. Now, of course, this is maybe not quite the right way to look at it in the sense that something I'm thinking about, because let's say if for me to go do an immunological paper is a pivot size of 1, but if I co-author with an immunologist, for them it might be a pivot size of 0. And so I bring in some econ papers. And so together we might pivot less, if you will. So part of teamwork might be sort of bringing you back into higher impact, right? And so, and then you could be more successful if that's what you're doing. But what this is telling you is that if you are working with new co-authors, but everybody's pivoting, that's not, when you're out there, that's not helping you, right? So that's sort of something we could sort of try to further unpack, but as a somewhat subtle distinction in how we think about collaboration in light of this penalty. All right, and then funding is, potentially interesting because resources might help you do high impact research, or communicate it, or do any number of other things that might have more resources, make it better. Okay, so the first thing is just look at the blue line. So this is the probability that your paper acknowledges a grant, a specific grant, right? And basically, the further you're pivoting, the less likely you are in general to be acknowledging a grant. Okay, So you're not, and that would make sense, right? I mean, because you don't have a grant typically to go do something wildly new. Maybe you don't want to admit it to the funder if you're doing something wildly new, so you're not going to cite the grant you're actually using to fund your PhD student. But anyway, but we see kind of less grants out there the further you pivot. And then with COVID, same thing. The further you're pivoting, the less likely you're to have a grant, but also you're just less likely to have a grant at all with COVID research. Again, because COVID's happening fast and people don't have COVID grants. The NIH and the NSF tried to come out with grants really quickly, starting in the spring and summer. And so we have that data as well. But that's kind of interesting, but it doesn't really change the picture. Just that when you're doing new stuff, it's less likely to have a grant. So so then that actually I think further raises the question that maybe what's going on with pivots not going well is because there's no money out there, and so you're maybe not putting as much financing into it. However, if you do our same cut, where we can now look at whether papers are funded or not, like does the paper acknowledge a grant or not, because there are some at all parts. Again, if you have a grant, you are going to do much better than if you don't have a grant for non-COVID work and for COVID work. But regardless of whether you have a grant or not, the further you're moving from your prior work, sort of the worse it goes. Okay. So again, this is something going on with grants, and maybe grants aren't good at getting people into new work, which is kind of interesting. But it's also the case that it doesn't sort of solve even high pivot work with grants is doing badly compared to low pivot work with grants. Okay. All right. So the final thing you can do is you can put all that together. We also looked at career stage, because you might think there's a whole other literature in creativity that talks about youth and sort of the plasticity of the mind, and sort of the older you get, the more beholden you are to a paradigm, and you can't sort of think outside the box, and you're young can sort of be more flexible. And I've done a bunch of work on that line and the life cycle, which tends to suggest it's not true, at least on average in the data. So for example, it's widely thought in entrepreneurship that that's the case. And I have a recent paper that looks at all the founders as census data for all new businesses in the US. And it actually shows that when you start a business that's in an industry in which you've actually worked, like in a really narrow sense, if you start the business in the same 6-digit NAICS code where you've been working for quite a few years, your probability of a home run goes up by like a factor of 2.5, right? So actually it seems like a premium to experience. And that's for like an upper 1 in 1,000 growth company. So like it seems like the really high tail growth companies are typically coming from people who are actually insiders, domain experts, not new to the area, where there's a penalty. And so, so anyway, we look at career age, like and also your career productivity. And I'll just tell you what you find. You actually find that younger scholars were less likely to pivot into COVID. So it was more older scholars, which might be a risk thing, right? Who have people who have the ability to, oh, sure, I'll do that. Why not? Not on the tenure clock, et cetera. And we found that it was very productive people who pivoted. So it wasn't the case that you're seeing a lot of garbagey sort of high pivot COVID papers, because it wasn't people who write very good papers. Actually, it was the high impact people who tended to engage, kind of more seasoned, high impact within their cohort. There's a huge increase in your probability of writing a pivot penalty with a sort of percentile of your impact within your cohort. Okay, so that's interesting. It kind of goes a bit the other way from kind of the young shall do the new flexible thing. It more seems again like the established people, and maybe for bad reasons. One way to look at that in a negative site would be to say that maybe a lot of talent got left on the sidelines because young people felt like afraid to do it, didn't have the resources to do it. Even the very productive young people weren't really writing COVID papers very much. So there's a lot of talent that didn't engage as well. Okay. All right, and then the final thing I'm not going to show you as well, but if I were to control for everything at once, like your past prior productivity and how many papers you write and how many co-authors you have and whether they're new and like do you have a grant, et cetera, you can sort of run a regression of lots and lots of fixed effects for these different things, and you still get the pivot penalty. It'll soften a bit. So I mean, like these things sort of there are ways to soften it, but like it's still there, okay, and pretty steeply. Okay, so I'll take a few minutes now to kind of put this in context, and then we turn to maybe a broader discussion. So if there's this idea in the creativity and innovation literature that the kind of big ideas come from the outsiders, we just don't see that in this data, at least the way we're measuring it and looking even in like the upper 1 in 1,000 papers. We're just not seeing some systematic advantage to novelty. We see a systematic disadvantage to kind of reaching far. And that's consistent with, we talked about researchers having narrow expertise. And this is actually what I just alluded to about the entrepreneurship as well, where you kind of domain expertise and having worked in that very narrow industry seems to predict success rather than the reverse. So it seems like it's maybe an increasing premium to kind of depth in the area. Actually, let me give you an example. This is the McClellan lab at UT Austin, also working with NIH. So they actually studied coronaviruses. Like that's what they do, and that and one other virus. And they sequenced the spike protein, the distinctive target for all the mRNA vaccines, and published a paper in January 2020. They're like, right immediately, like, Wuhan, give us the thing. Here's what's going on. Here's a therapeutic target. This paper, and this is like I did like a month ago. This paper is less than a year old. It was published. It's been cited 5,000 times. Okay, so these are the guys who didn't pivot. They didn't pivot at all. And the other people who didn't pivot are the mRNA people at like Biogen, BioNTech, and Moderna, right? Like this, we have a tool, the spike protein, we're going to run, and they're doing it really, and they're there like with a vaccine target and an actual vaccine like in a couple of months. So, you know, it's not the people who are further away, because there's an impact premium to COVID work, weren't necessarily doing important work. But this is just an example to sort of suggest that the people who could really deal with it were the people who are kind of happened to be, the world came to them in a sense, right? As opposed to them going to the world. Okay. So that's kind of that domain expertise. They really knew what they were doing and they could move. And it's particularly in a crisis situation, of course, especially quickly as well. All right. So with regard to explore versus exploit, you know, it sort of suggests that explore really is very difficult. And of course, that's the theme in the org literature, that it is hard. And I think you see a high demand opportunity, you want to jump to it. But in the org failure literature, that's thought to be difficult. And I think the linkage here is that it seems to be pretty hard to shift your existing R&D workers. So it wouldn't necessarily just be like a managerial failure. Like I'm Blockbuster, I just didn't see Netflix coming. You know, it'd be like, I can see Netflix coming, but I don't know what to do. That's not what we do. I don't have the team. And if you want to sort of think about it, this suggests that sort of trying to just redirect your R&D workers is going to be tough, especially in a deep area. What you probably need to do is acquire new relevant researchers, which is, you know, this literature on acqui-hires, for example, in entrepreneurship, or corporations going and trying to buy a company, not because they want their technology, but they want their talent, because they want people who really get that problem and know how to work against it. So that, you know, this is like all these companies buying AI teams, for example. Okay. From a policy point of view, you know, I mean, it sort of points to this limit opportunity again to shift your human capital and your resources to meet new demands, at least at first. I assume people could learn things over time, but at least certainly quickly, it's hard. And I want to emphasize, I think that kind of in an interesting way reinforces a portfolio motive. So you might think about doing a wide portfolio of basic research, like the NSF or the NIH, betting really widely because of the massive uncertainty about which doorways are going to open and show you. We don't know, you know, so you're searching into the unknown, so you don't know what you're going to find. So you want to kind of look very broadly. And that would be kind of an ordinary motive for spreading your bets in R&D investment. I think here in the crisis setting, you also get the sense that it's like a portfolio theory in finance, but you can't actually just sell stuff and buy them over here, right? It's very inelastic. There's a lot of inertia in the human capital you have. If we didn't have those mRNA companies and platforms, if we didn't have the, you know, the labs that happen to know about coronaviruses and we're ready to go, you know, I think the human cost of that would be very, very much higher, right? And so this suggests that there's a motive to spread your bets, in part because you don't know what's coming in terms of crisis, right? And that the idea that you're just going to pivot everyone to it when you need to, or effectively, that's probably not that realistic. Now, does that extend far beyond pandemics? I don't know, but of course we have climate change, we have like political polarization, issues that we all know, like, I want to say something about that. So maybe you feel like me. So like as an economist who has worked in policy, like most policy issues, I think, I've got a framework for that. And then I look at polarization in America and I'm like, I mean, I have some frameworks for that. I can tell you some stories, right, about the decay of the manufacturing heartland and trade, and, you know, I can tell you the stories. But it feels like there's something far more psychological, sociological going on. I kind of know there's other frameworks that are powerful and maybe they're really, really at the core of it that I don't really understand. So I feel like it hurts. It's harder for me to do effective work in that or feel confident about it. And so, you know, again, it says just you need to sort of spread people out to have the relevant kind of frameworks, and maybe through collaboration to engage these emergent challenges. Okay, so that's what I had prepared, and I'd love to take some questions.